Certainly, the eval function in Python is a powerful built-in function that evaluates a given expression of string S Python code. While it can be useful in certain contexts, it can also pose significant security risks, especially if user input is not properly sanitized. This can lead to code injection vulnerabilities, which can be exploited by attackers. Understanding eval, the eval function takes a string expression and evaluates it as a Python expression. As eval, eval, Here's a simple example Python basic usage of eval only to expression x. The result eval expression print result output 3 exploitation of eval when eval is used with untrusted input. An attacker can manipulate the input to execute arbitrary code. This can lead to serious security issues, such as data leakage, unauthorized access, or even system compromise. Example of a vulnerable application: consider a simple Flask application that evaluates user-provided expressions. Python from Flask import Flask, request app Flask name, app route eval, methods post def evaluate user input request form expression result, eval user input vulnerable to code injection returns true result if name main app run debug true. In this example, if an attacker sends a post request with the payload Python expression import O systemls, the server would execute the commandls listing files in the current directory, which is a clear security risk. How to exploit such a vulnerability? You could use a tool like curl to send a malicious request bash curl x post expression import Os. Systemls target import eval. This would execute the OS command on the server where the Flask app is running. Mitigation strategies: 1. Avoid using eval if possible. Avoid using eval altogether. Consider using safer alternatives like AST literal eval for evaluating expressions. Input validation: always validate and sanitize user inputs. Make sure that only expected input formats are allowed. Limit scope if you must use eval. Limit the scope of execution by providing a restricted dictionary of globals and locals. Use safer alternatives for mathematical expressions. Consider using libraries like SymPy or NumExpr. Safe implementation: example: here's how you can safely evaluate expressions using AST literal eval. Python import AST from Flask, import Flask, request app Flask name app route eval, methods posted def evaluate user input request form expression true. Uses AST literal eval to safely evaluate basic Python literals. Result: AST literal eval user input only allows literals except vo. Syntax or return mayo. This bool is taking of zero view is zero so the zero is zero zero the zero the this the zero the shushu the zero is very the zero value zero zero that's zero. Value zero. Really show zero. So we so zero. That really. Wow, so zero. I will do zero you the I will do zero. I will go do it. Conclusion: the eval function in Python can be dangerous if not used carefully. Understanding its risks and applying best practices for input validation and sanitization can help protect against code injection vulnerabilities. Always prefer safer alternatives when possible.